Good afternoon. All right, so Weston, how'd you do in Skills USA?
So I got the gold for welding sculpture, so I get to go to Louisville, Kentucky for the national competition.
Nice. Nice. All right, and how did your ball game go, Tobias?
We lost to Safford, but then came back and beat Pima and St. John's.
Okay.
Then we lost to Miami in the consolation game or whatever.
So you finished fourth?
Yeah.
Well, that's not too bad. Jada, are you there? And Opie, I know that that camera was working an hour ago. I don't know what happened to it. Seems to be out of focus. But are you there, Jada?
Jada will be in.
Okay. All right. Can you see on the touch 10 unit? Can you focus? See if you can focus that camera. All right. All right. So, according to my notes, we had a little bit. The last practice problem to go over in 10.4. And then we're going to go on to 10.5 today. So let's see here. Yeah, it's still fuzzy.
Mr. Strong,
Yeah.
I was wondering when the video for the last class is going to be up.
That is a great question. What has happened is that the last 2 weeks the videos aren't saving correctly. I mean, they're saving, but somehow they're not uploading to NBC's server. And so I got another email this morning saying that they're still not available. So
Okay.
I'm gonna anyway, I'm gonna check on it after class, and hopefully, maybe there'll be some progress before class tomorrow. But in the meantime, really the last 2 weeks are not going to be available. So,
Okay.
all right, well, that's good. That's better. At least I can kind of, oh, wait. So whatever just happened, that helped a lot to see Jada. I mean, she's still blurry.
She's still
we
probably won't be able to fix it till after class.
Okay, all right. Yeah, I probably couldn't identify her in a police lineup, but at least I can know it's her. So that's good. Thank you. All right. Well, when do you so Weston, when do you go to nationals?
I think it's the last week of June.
Oh, okay. Well, good.
Yeah.
I was gonna say I just hope it's after the second week in May. That's all I ask. So
Yeah.
So speaking of which, let me just so you can kind of pencil it into your calendar. Right now, I'm tentatively, I mean, I don't, we could move it up depending if we're ready, but right now, I'm tentatively scheduling the final for May 8th and May 9th. So if you guys have anything going on, check and let me know. Okay?
I know that May 9th is Navit Welding graduation.
Okay. Oh, we ran into that last semester, didn't we?
Yeah.
Okay, so
I could probably take both sessions on May 8th.
yeah, maybe that's what. Let's plan on doing that, or if somebody else has a conflict, then we can move it up a day. Okay.
Okay.
So let's right now let's plan on you taking both sessions on May 8th, and then basically then that gives me Friday the 10th to do your grades and submit them. So that's kind of my plan. And then the 11th, they actually have commencement for MPC, but I don't have to worry about that. So anyway, so just kind of pencil those dates in. Okay. Tobias, you check your sports calendar. Jada, check your calendar. Make sure that we're good those days. And we'll go from there. Okay. All right, so we were kind of on this problem right here last time. Does this converge or not? Okay. And so one of the things that if you look at when we did the comparison test, then what you do is you compare it to a series that converges or diverges. Okay. And so I think we even started on this and we said, well, if we guess that it diverges, we can compare it to 1 over n. All right. And so you put the series that you're comparing to on bottom to the series that you're given and then simplify. So dividing by 1 over n is the same as multiplying by n. So we get that. And then when we plug in infinity, we get infinity over infinity. So then we can use L'Hopital's rule, which says then we can take the derivative. So the derivative of n is 1. The derivative of n, ln of n, we use the product rule. And we say, actually, I'm going to put the 1 there. So the derivative of n is 1 times ln of n plus n times the derivative of ln of n, which is 1 over n. And then the bottom, the derivative of n squared plus 5 is 2n. All right, so then when we simplify, this gives us 1 plus ln of n plus 1 over 2n. And once again, this is going to get us infinity over infinity. So we take the derivative again. So the derivative of natural log of n is 1 over n. The derivative of 2n is 2. And so as n approaches infinity, we get a constant over infinity is 0. Divided by 2 is still 0. So what does that mean? For this was the comparison test, the limit comparison test. What does that mean if we get 0?
Doesn't it mean we get nothing out of that?
We get nothing, right. So I think we had got to that point, didn't we? It tells me nada, so that means we got nothing out of that. We have nothing. Okay, so when you're doing the term comparison test, then if you get nothing, then and you compared it to a divergent series, then what I would suggest you do is compare it to a converging series. So what's a converging series that you know?
Is 1 over n squared converging?
Yep. That's a P-series. So with P is 2, so that's the one, in fact, that I would compare it to. Okay? So this one didn't work. Whoops. So now if I compare it to 1 over n squared, so that's this is a converging, I'm going to write that, converging P-series. Okay? So now I go through the same thing, put the 1 over n squared on the bottom, and so when I invert and multiply, then I get n squared plus n squared ln over n squared plus 5. Infinity over infinity. So I can use L'Hopital again. So the derivative of n squared is 2n plus, then I have 2n ln of n plus n squared times 1 over n all over 2n. So if I simplify that, this is going to simplify to just n. So I get 3n plus n, 2n plus n is 3n. So I get infinity over infinity again. So I'm going to use L'Hopital again. So the derivative of 3n is 3. The derivative of 2n ln of n is 2 ln of n. Here, actually, this is not exactly correct here. So I get 2 ln of n plus 2n times 1 over n, all divided by the derivative of 2n is 2. All right, so this gives me 2 plus 3 is 5. But the derivative, so I'm going to get infinity over 2. So that goes to infinity. All right, so now what does that mean? So I compared it to a converging series, and I got infinity.
That doesn't tell us anything either.
This doesn't tell us anything either. Okay? So I guess I kept going here. Also tells me nada. Because if you get infinity, when you compare it to a converging series, that tells you nothing. All right? So then what I've done here is I've compared it to a converging series, got nothing. Compared it to a diverging series and got nothing. So I could keep beating the dead horse here, and maybe I would get lucky, but usually after I've compared it to a converging series and a diverging series, then I will quit with this limit comparison, and I will do a different test. Now, that leads us in perfectly to the next section. We're going to learn some more tests. Okay? But with this is sort of the drawback of the limit comparison test is you could do a lot of work and get nothing, not have nothing to show for it. Okay? All right. So All right. Well, let's. So now I want to go take you to some other tests. Okay. So in 10.5, we're going to learn about an important idea called absolute convergence. And then I'm going to show you two more tests, the ratio tests and the root tests. Okay. All right. So any questions on 10.4 before we leave it behind? Okay. All right. So the next idea is what's called absolute convergence. Okay. A series converges absolutely or is absolutely convergence if the absolute values of each term converges. Okay. So, like, for example, let's say you look at something, a series like this. This looks awful. But really, the alternator here, -1 to the n minus 1, this is causing the signs to alternate. So basically, if we cover that up, then all the terms will be positive. And so it's kind of like by covering up the alternator, then we can say, okay, what about this? Well, now this is a geometric series where you were multiplied by 1/2 each time. And so that converges. So this series converges absolutely. So it's like saying its absolute value converges. Okay? All right. Now, this is an important idea then, the absolute convergence test. If the absolute value of a series converges, then the series converges. So if you can cover up the repeater, the alternator, and get it to converge, then the series is going to converge. So if the series converges absolutely, the series converges. Okay? All right. So here we want to know, does this series converge? So what you do is, it's like you cover up the alternator and you say 1/n². Well, we just talked about that series. That's a converging P-series where the P is 2. So if we cover up the alternator and this converges, then that means this original series is going to converge absolutely, which means it converges. So it's a converging P-series. And so the original, this is going to converge. Because if it converges absolutely, it converges. Okay? All right. So let's take a look at this one. See if you can kind of reason this one out. All right, so let me switch it. All right, so Weston, do you have what do you think about this one?
I'm not sure.
Okay, so let me see if I can help you a little bit. What if instead of sine n in the numerator, it was just 1? So
Then
1/n².
it converged because it's a P-series.
Okay? Now, is sine n always less than 1? Less than or equal to 1?
Yeah.
So sine, the biggest it goes is 1.
Yeah.
Okay, so then what would that mean?
That it should converge.
Yes, because it's less than a converging series. The other way you could think about it is you could think that like sine goes from -1 to 1, and that's it. And so if you thought about the absolute value, you could do it that way. But see, I just think of it as the absolute value of the sine is less than or equal to 1. Or the sine has to be less than or equal to 1. And so if you put a 1 up here, the series converges. So since it's less than a converging series, then it converges. Okay? Does that make sense? Okay. Okay. Let's see what we got here. Okay, so just a little quick review. So we learned the nth term test for divergence. So that's where you take the limit as n approaches infinity. All right, then we have a geometric series where if you multiply each term by r. And if the r is between -1 and 1, the series converges. Otherwise, it diverges. Okay? We know the harmonic series diverges. The P-series, 1 over n to the p, if p is less than or equal to 1, series diverges. If p is greater than 1, the series converges. All right, we've learned the integral test, where you take the integral, and then last section we did the comparison test, the limit comparison test and the term comparison test we did last Wednesday. So to add to that, these tests, today we're going to add the ratio test and the root test. Okay. All right. Now, it says, let the sum of the a sub n's be a series, and suppose that the limit as n approaches infinity of, so for the ratio test, you're comparing the n plus 1 term over the nth term. And they were saying, suppose that the absolute value of that is rho. Now, I know this looks like a p, but they actually use the Greek letter rho for, it's like r for ratio. Okay. And so here's the result. So you get a number. Well, the series converges absolutely if the rho is less than 1. The series diverges if rho is greater than 1 or infinite. And then the test is inconclusive. You get nothing if rho is equal to 1. So that's what you don't. In the last one, you didn't want your result to be 0. In this one, you don't want it to be 1. All right. So let me kind of show you how this works. Oh, now a couple of things. When we do the n plus 1 term, okay, just know that like if you're canceling, if you have x to the n plus 1 divided by x to the n, when you subtract the exponents, that's just going to give you x to the first. Okay? So like if I have 3 to the n plus 1 over 3 to the n, that I would subtract the exponents, and I would just get 3 to the first. Okay? Same thing when I have the n plus 1 term with a factorial. If I have n plus 1 factorial over n factorial, then see, like factorial is like if you have 5 factorials, 5 times 4 times 3 times 2 times 1. If you have n plus 1 factorial, you break that down to n plus 1 times n factorial. So then you can cancel the n factorials, and so you would just get n plus 1. So n plus 1 factorial over n factorial would just simplify to n plus 1. So that's just a couple of canceling strategies there. All right, so now let's look at an example here. Okay? All right, so let's say I'm trying to determine if this converges or diverges. So I'm going to use the ratio test. So I'm going to put this down here at the bottom, and then everywhere I have an n, I'm going to plug in n plus 1. So I have 2 to the n plus 1 plus 5 over 3 to the n plus 1, divided by this thing, 2 to the n plus 5 over 3 to the n. All right, now to simplify that, you invert the denominator and multiply. So you have the limit as n approaches infinity of 2 to the n plus 1 plus 5 over 3 to the n plus 1 times, so then you flip this, 3 to the n over 2 to the n plus 5. Now, the 2 to the n plus 1 plus 5, you can't cancel those. But this you can. So what would 3 to the n over 3 to the n plus 1 simplify to? So the 3 to the n and 3 to the n plus 1, what will that cancel to? All right, Jada, what do you think? Just this part. 3 to the n over 3 to the n plus 1.
1 over n?
It'll cancel to 1 over 3.
Oh, okay.
Because see, when you subtract the exponents, you get n minus 1. So you're going to have a 3 to the minus 1, or a 3 in the denominator. All right? So that will leave you with 1 over 3 times 2 to the n plus 1 plus 5 over 2 to the n plus 5. All right, now, you can't cancel anymore. So you plug in infinity and you get 2 to the infinity, which is infinity over infinity. So now you can use L'Hopital's rule. So you're going to take the derivative of each. So now we're going to use this rule up here, that if we have a to the u, the derivative is a to the u times the natural log of a times the derivative of u. So the derivative of 2 to the n plus 1 is 2 to the n plus 1 times the natural log of 2 times the derivative of n plus 1, which is 1. So I didn't put that in. Then the denominator, just bring down the 3. The derivative of 2 to the n is 2 to the n times the natural log of 2. Then the derivative of the 5's cancel. All right, so now we get the natural log of 2's cancel. 2 to the n plus 1 over 2 to the n. That'll cancel, leaving me with just 2. And then in the denominator, I just have 3. So that limit is just 2/3. So if rho is 2/3, see, if rho is a number less than 1, then the answer is it converges. So if my limit is 2/3, then my problem converges. All right, any questions? All right, let's go back up. All right, so I want you to try, what is that? Practice 2A. All right, so let's see if you've got just the first step set up correctly. Okay. All right, so we have, 2n factorial over n factorial goes on the bottom. And then everywhere there's an n, I plug in n plus 1. So I get 2n plus 1 factorial over n plus 1 factorial, n plus 1 factorial. Now, this 2 times n plus 1 factorial, that's the same thing when you distribute the 2, you get 2n plus 2 factorial. So you end up with 2n plus 2 factorial over n plus 1 factorial, n plus 1 factorial, times n factorial over 2n factorial. So, Tobias, how do I simplify that?
I'm not gonna lie, I honestly have no idea.
All right. Well, that's kind of why I'm trying to help you a little bit on this one, because it's a little tough. Weston, how about you? Do you know how to simplify that fraction?
Could one of the n factorials cancel with the other n factorial, and the n plus 1 factorial cancel with another n plus 1 factorial?
Okay, so how would it cancel? You're right, it is going to cancel. But how do you make it cancel? See, what you do is the n plus 1 factorial, you can write that as n plus 1 times n factorial. See, it's kind of like, let's see if I can help you understand what we're doing here. It's kind of like if I had, if I had like 7 factorial over 5 factorial, then see, I can write this as 7 times 6 times 5 factorial over 5 factorial, and then these will cancel. So if I have n plus 1 factorial over n factorial, I could think of that as n plus 1 times n factorial over n factorial, and then those will cancel. So it's just kind of breaking it down. Okay? So going back to this, then what I do is I think of these n plus 1s as n plus 1 times n factorial. And then the n factorial part is going to cancel with each of those. All right, same thing with the 2n plus 2 factorial. I think of that as 2n plus 2 times 2n plus 1 times 2n factorial. And now the 2n factorial will cancel with that 2n factorial. Okay, so now I cancel the n factorial here and here, and so I'm just left with n plus 1 and n plus 1. So then in the numerator I have 2n plus 2 times 2n plus 1. Well, now I can factor out a 2 from 2n plus 2 and get 2 times n plus 1, and then I can cancel one of those. And so then what I'm left with is 4, let's see, so 4n plus 2 over n plus 1. Then using L'Hopital again, that ends up just being 4 over 1, or 4. So that goes to 4. So, it looks pretty complicated here, but those, when you break down those factorials, they're going to cancel. All right, so what does that mean that we got a row of 4. Our answer is 4.
Does it diverge?
Then if we get a row that's greater than 1, then the series diverges. Okay? Anything greater than 1, it's going to be a diverging series. Okay? All right, let's try, let's see, that was practice 2. Let's try practice 2B. Let's see, wait a second. 2, let's see, 2, yeah. Try practice 2B. So I'll leave this one up for a minute. I don't know if it helps or not, but. Okay, so this is the a sub n plus 1 term. So everywhere there's an n, you just replace it with n plus 1. So 4 to the n plus 1 power times n plus 1 factorial times n plus 1 factorial over 2 times n plus 1 quantity factorial. So then this is going to be your limit that you're going to take. Okay, so make sure you got it set up and then start canceling. All right, so Tobias, did you get an answer?
Well, I did get an answer. I don't know if it's like anywhere near right though.
All right,
So-
well, tell me what you got.
Okay, so I don't know if I did L'Hopital's rule right, but I think I got 1/4 over 4, which
Okay.
that's what I don't know.
So,
But that
well, let's make sure that you simplified everything correctly here first. So, when you simplify everything, see 4 to the n plus 1 over 4 to the n simplifies to just 4. And then n plus 1 factorial over n factorial just cancels to n plus 1. Same thing again. And then 2n plus 2 factorial is 2n plus 2 times 2n plus 1 times 2n factorial. So then the 2n factorials cancel. So you just get 2 times n plus 1 times 2n plus 1. Okay? So here so 2n plus 2 factorial is 2n plus 2 times 2n plus 1 times 2 factorial. And so then when you cancel the 2n factorial, then you're left with 2n plus 2 times 2n plus 1, or 2 times n plus 1 times 2n plus 1. And so then the 2n plus 1, or the n plus 1 cancels with that n plus 1. So you have, and the 4 cancels with the 2. So you're left with 2 times n plus 1 over 2n plus 1.